All right, so in this video, we're going to summarize what you might have missed on Zoom class on Thursday, December 3rd, if your computer was lagging or anything like that. So a couple of general announcements, right? I saw some of you working on fixing those performance tasks. When you are done, this is just a reminder to email me, or if this announcement makes you go, I probably want to bring my grade up and I need to do that, but I don't know how. Feel free to email me for help, right? Or you can go to office hours on Tuesday, linked in your Schoology page right here. The other thing is tomorrow you're going to have an open notes quiz on lesson 2.1 to 2.8. So if you're a little behind on your Nearpod lessons, please come to class on Friday anyways. I'm going to do a quick check-in with you where I'm going to give you alternatives to catch up, and I will meet with you to make sure that we are all successful, right? Okay, so for your quiz study guide, notice that's on Schoology on the right-hand side in the upcoming. If you click on this link, Unit 2 Open Notes Quiz on Friday, December 4th, if you click on that, that is your study guide. So your study guide, Nearpod lessons on everything that's going to be covered is located here. Practice problems, if you scroll down below, scrolling up at the very top is the answer key. You might have to double click in order to open that up. Right, so today we talked about how new elements are created. And essentially, I'm going to skip through some parts. So here in this video, it's a little bit lagging. So in this video, we talked about how new elements are created. And essentially, they're created in the stars, like our sun, for example. In the sun, it's super hot and it's super bright, right? It's the reason why we have daytime. But what's happening in the sun is essentially we have all these elements crashing into each other and fusing together as one. So they're like whizzing around super fast, and when they crash, they fuse together to form a new element. Right? So how does this actually work? Right? Looking at this, if we look at these two elements here, right? Notice that I have one proton, two proton, and they're kind of separate elements right now. So if they crash into each other, like this one moves here, this one moves here, they crash into each other, I will end up with an element that has two protons, right? So they just kind of combine together and fuse into one element. Boom, like so, right? So every single time we look at a star, this is happening right now. So all the atoms in that giant fireball of a star, they're crashing into each other, making new elements. So another thing we're going to do in this unit is figure out what new elements can we make, right? And the reason why we know that or want to know that is because some of these elements are going to help us identify treatments for specific types of cancer, right? So scrolling down to the next slide, right? If I could actually look at the sun, so these are two elements and then they crash into each other, forming a brand new product, right? And that was the thing with the two protons. So this process that we talk about is called fusion. And you're going to learn more about this when you do Nearpod lesson 3.5. But I think you could probably be able to figure out what new elements are made in lesson 3.5 without actually having me teach you anything. So if I showed you the element cards like this again, this is essentially the same thing as if these two elements were combining together. So they're crashing each other and they're going to fuse into one, right? So when they fuse into one, notice that what's happening here is essentially you're kind of adding the numbers up, right? So for example, our top number up here is what's known as our atomic number, or the number of protons. So if I have one proton and they combine, I will make a new element with two protons. And remember that the mass is the number of protons and neutrons together, right? So if you add these two up, the mass is going to be 3, right? So here's the tricky part. How do I figure out what new elements I've made? Just by going off of these two numbers, right? So if my top number is 2, this is my atomic number, or my number of protons. And this is the one that's going to help me figure out what elements I have, right? So what I'm going to look for is elements number 2 from ptable.com. So elements number 2, so element number 1 is hydrogen. So looking at the upper left-hand side, this is hydrogen right now, because the top number or atomic number is 1. The second one, helium, is element number 2, because my atomic number or number of protons is 2. Right? So if this number is 2, I'm looking for element number 2, which tells me that this is helium, or He. So this is going to be He, helium, with a mass of 3 and 2 protons, right? So go ahead and pause this video and see if you can figure out what element this is. And again, you definitely want to go to ptable.com. If you just type in ptable.com, this page should pop up. Right? So go ahead and pause this, see if you can figure out the top number, bottom number of the mass, and what elements you make. And unpause when you're ready. Okay. So here, my top number, 2 plus 3, is going to be 5. 4 plus 7 for my mass is going to be 11. And again, I'm going to use the top number to figure out what elements I have. So looking at ptable.com, I'm looking for top number, which is element number 5. It's right here. Let me click on that. So element number 5, it says 5 on top, so it's going to be B, boron. All right, so I have boron for this one. Okay, so let's see. Let's take this a little further. All right. So sometimes if you're looking at stars, you have a whole bunch of different elements at the same time, just whizzing around, crashing into each other and fusing together. So here, if I want to try to make neon with 10 protons or an atomic number of 10, what 2 elements do you think you can combine in order to make neon? Now, this one has so many answers. So if you want to look through, think about this, there are so many answers. So go ahead and pause and unpause when you're ready, and then I'll do a couple. Okay, so you might have boron element number 5 again, right? Or you might have carbon, which is element number 6, with beryllium, which is element number 4. You might have element number 2, which is helium, with element number 8, which is oxygen. What else could you have? Let me think. You can have nitrogen, which is element number 7, with lithium, which is element number 3, so on and so forth. I'm pretty sure there are a couple that I haven't thought of yet, but here, right, these are all the possibilities that can happen when you combine two elements together. Right? So because of all these possibilities, you might end up with something weird happening like this. Right? Sometimes if you have something like this, I want you to notice what's the difference about these two types of lithium. Right? So go ahead and add these numbers up. Your top number and your bottom number. See if you can figure out what's weird about this lithium. Right. Okay, so you might notice that when you add these up, the top numbers are the same, meaning you have the same number of protons or lithium. Your bottom number or mass is going to be a tiny bit different, right? So this mass is going to be 4, 3 plus 1 plus 3 is 4. And this bottom number, 2 plus 3, is going to be 5. So you notice that, hey, this mass, the top mass, is smaller than the bottom mass, right? And that just has to do with the randomness of all the collisions that are occurring in the stars. And whenever you have two elements that have different masses, right? This mass is different from this mass, but they're the same elements. We call those elements isotopes, right? And we're going to talk more about isotopes in Nearpod lesson 3.6, right? So our key focus goals in our Nearpod lessons is 3.5, how to make new elements. So that was when we were doing things like this. And 3.6 will focus on isotopes, right? Why do these weird isotopes or types of elements exist with different masses? Right. So let's go over how to find your Nearpod lessons and all of that good stuff and your exit ticket as well. So I'm going to go ahead and go back onto the main page of my Schoology. And there are two locations where you can find the homework. All right, so if you're watching this before the due date, Monday, December 7th of the homework assignment, you should see it in the upcoming on the right-hand side. If it's past that time, go ahead and go into the week 6 folder. December 3rd, Thursday, the one titled Homework, Topic 3, Atoms versus Cancer. When you click on that, the first two links are the links to the Nearpod lesson. Right? And notice that in step 3 and 4, it tells you to open and work on a worksheet. On your version, you should see a button that says View Document up here, and then a button on the right that says Edit Documents. Right? So when you click on that, you'll see a link that says Isotopes Worksheets. And it looks like this. So in Nearpod lesson 3.6, I go over 2 practice problems, and they're actually in your homework, right? So if you watch Nearpod lesson 3.6 carefully, I go over how to find the answers for these 2, right? So that's pretty much it for today. If you want to double check to make sure that you are correct in certain things, right? If you go on to December 3rd Zoom class links, you can find the link to the exit tickets here, right? Alrighty, so that's pretty much it for December 3rd, Thursday.